I will basically be talking to you about triboluminescent materials for structural health monitoring. So maybe some of you will be wondering all this, that may be a new word for it. Example, triboluminescent. So by the time we are through, you should be able to know what it is. Luminescent, you know. And then there is a health monitoring, you know. But structural health monitoring may also be a new concept. Say, of a structure, we also want to see the structural health monitoring. So I will just go through this slowly, and if you have any questions, you can stop me, and we'll go from there. So first of all, I'll try to see how we understand triboluminescence. So first of all, let us see what is luminescence. So I have written luminescence is the emission of light of a wavelength different from that of the absorbed by the material. So if you basically, I did not bring all my stuff, but in the lab, you are here, come by, I'll show you. If you put something like ultraviolet light on some material, and if it is a luminescent material, it will give you the luminescence, like tonic water, so to say. Tonic water, if you see in ultraviolet light, it kind of glows. So essentially, that is a general name for it. Then we have some fluorescence. When the material glows and it absorbs radiation, when the light source is removed, it immediately ceases to glow. So you have seen also something like that. Phosphorescence is material glows after the radiation source is removed. So if you have ultraviolet light, you shine on it, it will start glowing, and take the light off, even then it will keep glowing, right? So you must have seen, I don't know how many of you have gone in some mineral and shows, and they have inside a room, they have all kinds of different rocks, and put your UV light, somewhere it is red light coming, somewhere different colored lights are coming. So that is like phosphorescence. So there are a variety of such phenomena. This is some of our students. They have come up with this thing. You know, it's a light bug at night. You can just see. So this is the fluorescence. You can imagine this is tonic water, and if you put some ultraviolet light on it, it will show you the color. So when the material glows, that is absorbs radiation. When the light source is removed, it ceases to glow. In fact, in today's, it is very exciting these days, like YouTube, right? If you go to YouTube and want to see, there will be a lot of demonstrations on anything you want to learn, right? So you are in a very exciting time, really. So this is phosphorescence, that is material glows after the radiation source is removed, right? So there are many things which are like, this is like a gel kind. It's not very clear, but there is a picture of the person here in a hand. He's trying to take this, and then when the light is removed, it is glowing, right? So essentially, physics-wise, I don't know, you have seen this model somewhere. Everything is made up of atoms, and in their atoms, they have these electron states, and the spectroscopists. They are experts in this room, but basically they just whenever the light is absorbed, it goes to some higher level state, and then whatever it comes out, it converts to light. So if it is immediately, then it is fluorescence, otherwise phosphorescence. Okay. So essentially, this is the technical part of it. Again, this luminescence can be excited by many types of energy. Right? So photoluminescence. Photo means if you put light on it, it will basically give you like often ultraviolet light. It gives out some electromagnetic radiation. Now chemiluminescence is a chemical reaction happens, and basically I have some couple of things like that. We have this time, so you can break this here. You can start give that student. You break it a little bit, break it, and then keep breaking, and you will see the light. Right? Give it to your friend there. let them break something, different places. It will be basically two chemicals get into, okay? You can even start this. This is another one. It is a, you can break that too, yeah, you can break like this.
Usually the chambers the cow.
Yes, just break.
Maybe it's
Yeah.
the cow.
And then you just go give him break it, break more and stuff. So essentially, the whole thing will glow. All right. What is happening is these are the two chemicals in there, right? So when two chemicals mix, the light comes up. So you can see that this is the this is called chemiluminescence. Right, I was going to bring that other thing to photoluminescence, but it was like too UV light and all that. But essentially, you see all that glowing, that one, and you can push it down and just shake it more, right? You can just show it. You see here, you can. It is all right. So essentially, you see that this is chemical luminescence. This is very commonly available, and there are two chemicals. If you mix them, you just basically do that. Thermoluminescence. You can excite this thing by thermal energy. Then electroluminescence, or electric volts, right? Electric voltage. Then we have cathodoluminescence. Right? Once you have, there is a host of things which you kind of cathodoluminescence by a beam of energetic electrons. Then acoustoluminescence, then visible light if it is due to the acoustic vibration of single crystals in media. Right? Then you have sonoluminescence. All right. So essentially, by ultrasonic cavitation of liquid water. So there are various names, but basically light comes out there, right? Now comes this triboluminescence. It is the property by which some materials become luminous upon being scratched, crushed, or rubbed. Right? This is like it is very fanciful. If you see crush a stone and light comes out, right? It is like something. You want to see, hey, it is very, very interesting. If you scratch, crush, or rub, essentially, it's a very old phenomenon, but it's that's how I say triboluminescent phenomenon. Okay, so this is you define triboluminescence as the light emitted when the electron is stressed to the point of fracture. That means if you fracture anything, then you have, we call this as a triboluminescence, right? Essentially, this was known in 16th century, right? When the sugar was almost invented, and then they were making big blobs of sugar. When they used to break it, then the light will come out. So basically, when you break sugar, the light used to come out, but it was not of much use. We wanted, now only in the later part of 20th century, we could see it better. But this is another thing you might have played when you were very young. Wintergreen Lifesavers, right? When there are two little, when you play around, crush it in your mouth, the light comes from the mouth, right? If you're in the dark somewhere. So that is also sugar crushing. Then we want to understand what is the phenomenon, right? So here, crushing wintergreen thing here. See, this is a little on this corner. I didn't blow it up, but if you put a hammer on the wintergreen thing, right, it produces light. Or if you crush with something, you will also see it. So basically, we want to understand what is this triboluminescence. So maybe when you break, there are positive charges on one side, negative on the other, and then during that, there is some kind of a spark which goes the positive to negative. Okay? And then as the pieces of candy move apart, the charges want to get back together and they jump across like tiny lightning bolts. So wintergreen flavor intensifies the light. Okay, so essentially, this is a normal thing you can see by something like Wintergreen Lifesaver and try. This is a picture taken if you put a wintergreen with a hammer, right, and load down, you will see the lights like that. Okay, so triboluminescence is first thing which we want to learn, and it comes from these two words. Tribal is to rub, and human means light. So when you crush it, the light comes out. Right? There are many other names, mechanoluminescence or fractomechanoluminescence, elastomechanoluminescence. Of course, you understand that triboluminescence means when you crush or break anything, the light comes out. Right? So that is the triboluminescence. These other names of this phenomena could be piezoluminescence. Right? Piezo is also pressure. Right? So when you press something, light comes out. Then deformation luminescence, impact luminescence, and this is, I think, German word Trennungslicht, and stress activated luminescence, mechanoluminescence. Okay, so other names are like that. So you want to know how does it happen. Okay, so as of now, we really don't know exact explanation of really what is happening, because there are lots and lots of materials where this happens, and we want to know, we want to find the best material which gives us maximum light output when you break. So we have some kind of observations on whatever material we have. So this is the thing which I told you, that when you crush this, there may be a positive charge there and a negative charge there, and then the electron is going from there, and basically this UV light, and then it basically, we know that when you crush in the maw, there is a bluish light coming out. So this is one kind of explanation that you can see. Okay. We also saw that this happens more frequently in crystals where the structure lacks a center of symmetry. So it does not, you don't see it in like symmetric kind of crystals. So first thing is, okay, anything which this will show has to be a non-centrosymmetric crystal, right? So any crystal we will put our hand on and see whether it is centrosymmetric or not. This suggests that piezoelectric effects play an important part in the production of TO emission in some materials. So essentially, we are trying to come or understand the mechanism of what is happening. And there are various different mechanisms, and I will, as I go further, we have done some research, and I'm going to get in there. So first thing is, you will know what is this triboluminescence, and this other thing is the structural health monitoring. The health monitoring part, let me see if it will come, let me tell you something, and then I will go into some of the materials which we have done. So in the structural health monitoring, it is like you have an airplane or a space shuttle. You want to see after so many runs what is the health of the structure. Or you want to go on a bridge, right, after so many years, whether the bridge is of sound health or not, right? So Dr. Sharma has come up with some kind of, fiber, optical fiber, which you can put in the bridge, and it will tell you after some time there are some parts which are broken. Now, we also know about the airplane, whether it is it has the health of the structure is good or not. We want to also know the health of the space shuttle or space vehicle which goes up. Now that is, we are trying to see based on our own health, right? Our health is, wherever our body is, everything is sensors, right? Where you touch, if I touch you, any